Hello, this is Greg Deckler, and welcome to Microsoft Hates Greg. So, just to start this video off, I have to say that of all the crazy, impractical, and ridiculous things that I've done with Power BI over the years, this one takes the cake. And that's saying a lot, because I've done a lot of crazy, ridiculous, impractical things with Power BI as a long list. But this one is at the top, I feel. And it all revolves around the forecasting that DAX has for line graphs. So as you know, as probably most everyone's aware, if you have a line graph and you have a continuous axis, x-axis that is based upon date, you can actually do forecasting within Power BI. And you can go to the analytics pane, you can do the forecast, turn it on and give it some parameters, or mostly it works kind of out of the box, if you will, to a large degree. In this case, we have a forecast length of 24 months, and you get forecast values back, right? So this is, let's say this is like historical sales data or something like that, or inventory data, and then this is, you can get forecasted values for what is going to be out in the future, with a upper bound and lower bound. Now this is great and all, except the problem is, and this came through a LinkedIn request, they were like, well, we have this requirement where, we can do the forecasting with the line graph, but we can't actually like access or use the values in the forecast in DAX functions or anything else. So they asked, do you know of a way to do this? And I'm like, no, I don't know any out of the box the way to do that. And I, replied with, well, you'd probably have to do is reverse engineer this forecasting algorithm that Microsoft is using, implement that in DAX, and then you could calculate out the values. Sounds simple enough, right? I already knew it was not going to be, because I had actually done some research on this in the past, and there's a blog article from 2014 describing the forecast models in Power BI. And I remember reading this when this forecasting feature came out, and this blog article came out, because I was kind of interested in how they were doing the forecasting. And if you read through the article, right, they talk about this, ETSAA algorithm, seasonal algorithm, then it's based on the Holt-Winters algorithm. So the Holt-Winters algorithm is how they're doing, this for like seasonal. And seasonal basically is cyclical data. Think like retail sales is the classic example of seasonal data. And then they use a simpler version for non-seasonal data. So of course I'm going to pick the hard one, because I'm a masochist apparently. But I figured if I can get it done for the hard one, then the easy one will be, easy. So this video and this approach that I'm going to show is based upon the seasonal algorithm. All right, so of course then I have to figure out, how does the Holt-Winters algorithm actually work? Did a bunch of Googling around, binging around, searching around, and I came across this article by Gregory Trubetskoy. I hope I'm pronouncing that correctly. Of course, I skimmed parts 1 and 2. They kind of the setup. They're using the easier, introducing concepts and showing, the non-seasonal way of doing things. And then once you get into the seasonality, you have to do the triple exponential smoothing, which sounds kind of dirty, but I'm sure it's not. It's AKA the Holt-Winters method. So you basically, here's your 3 different things that you're smoothing: level, trend, seasonal, and then of course you use that to calculate your forecast. Okay. So what they did is they have a nice example here. They don't explain the code very well, as it were. They just kind of show, here's the code. But they do provide a full example, and there's actual results that I can compare to, right? That's super handy when you're trying to replicate anything. But it's Python. Why? I feel like Indiana Jones. Why did it have to be Python? Anyway, so they have this, here's their data series, right? And then they've got it plotted here. And then there's a function definition for an initial trend. And then they have another function definition for initial seasonal components. And then they have the triple exponential smoothing algorithm. And there's actually 3 different parts to this. There's like basically initial, the initial one. This is, you have to initialize it using that initial trend definition. And then if it is a prediction, it actually uses a different calculation. And then if it is not a prediction, so it's a historical value, then it uses, this code right here. And so, and I'll have this link and a link to the PBX file that I'm going to use um, in the description. There'll be the PBX will be posted out on my GitHub repository for Microsoft Hates Greg. And then, once you go through all of this, right, you can actually plot the exponentially smooth values along with your predicted values, right? And there's some more notes in here on how you calculate. There's these things called alpha, gamma, and beta that you need, and how you calculate these out. I just use their values that they calculate. Apparently, there are ways to do it. I didn't get into all of that. The Nelder-Mead method or something, this is what Tigres does. Okay. I didn't get into all of that piece of it. Maybe I'll do that in a later video. Trust me, just getting the Holt-Winters algorithm to work in DAX was enough work. I spent an entire Sunday, and that was after I'd done a bunch of research on it. So here's the Python code, right? So I need to replicate this code in DAX. So how do you do that? But it is possible, even though it is a ton of work. Now, the thing that you'll notice that I should mention about this code is that, okay, we have looping involved here, obviously. We have this for loop, and you got for loops up here as well. You got for loop here, so there's lots of for loops involved. And then this has what I would describe as an element of recursion to it. I hesitate to say full recursion because I guess when I learned recursion in computer science, it's to create a function that calls itself over and over again to do recursion. This isn't that necessarily, but we do have to keep track of previous value. So what happens is going on in this code is that it's using basically, these variables like trend and seasonals and smooth and things like that and last smooth, but it has to use the previous values to calculate the next point on the graph or prediction or exponential smoothing. And you basically have to like start at the beginning and use this and calculate all the way through. And because then once you get to the end, whatever the values of these things are, that's what's used when you're doing predictions. So whatever the value of smooth is at the end and trend is at the end, and what the seasonal values are, those are what it uses for the prediction, but you don't know what those are until you kind of go through and calculate out all historical pieces. Sounds like fun, right? So trifecta of misery for Greg. We've got loops, we've got recursion, and it's Python. If you want to know why I despise Python, I have a blog article out there called Python Meh on LinkedIn, and you can read it. All right, so how do we do this in DAX? Well, it's not easy, I can tell you that, okay? So this is what I started with. Let's go ahead and show you the end result. So the end result is this top graph here. I still have the same thing I'm using down here. Now I'll explain the difference in the index here in a second. But as you can see here, I've got I can zoom in on this. You can see the light blue line is almost entirely covered up by the dark blue line, which is my exponential smoothing algorithm for the historical information. And then out here, the orange line essentially is my predicted values for 24 months out. And now it comes out pretty good. So like this is 22, this is 22, 22.425, right? 32 versus 31. 28 versus 28.8, right? So the numbers are not identical, 33, 32, even with rounding, right? The values are not, 100% identical. Why is that? I don't know. Probably different alpha, beta, gamma starting values, perhaps. Maybe they're using a different seasonal component for the algorithm. There is a footnote in this article that the seasonal component described here is using forecasting method and applications third edition by these folks versus Wikipedia has a different formula for the seasonal component. So they don't know which one is better. But I just, in order to replicate this, I followed this article specifically because that's the only way that you're preserve any amount of sanity because you have to be able to double check and make sure that you're getting all the same values for everything. Okay, so and I did confirm that I'm getting the exact same values for all of these data points that the Python code is doing. So everything checked out. So it is a true implementation of that. But how do you do it? Well, there you have it, right? So basically, it involves lots of tables. All right, so let's in each of these tables is an iteration through the loop where I'm preserving my previous values of things so that DAX can not get into circular reference. And so I decided to implement that preserving of those previous values as tables. Could I have perhaps done this in a single DAX measure? Probably, but I might have run into the character limit within the DAX editor. Okay, so let's just give you a quick peek on the data model. So this is the same Python, code. So I've got an index from 0 to 71. So I got 72 rows here. And this is the same data from what was being used in that series for Python. Now, in order to get this to work, because these are numeric, all right, in order to get it to work for Power BI's forecasting, I can't use numbers apparently. I have to use dates and they have to be continuous. So here I just converted, I essentially just I picked a base or a fictional base date of 2017, January 1st, and then I'm just using end of month to just convert these index values into dates essentially. So that way I could plot this and it would then I could get my forecast to work because forecasting is in Power BI and it has specific criteria, if you will. But for this case, I didn't need to do that. I could just use the index values and then plot them. All right, so so the first few things, alpha, beta, and gamma. So I just created measures for each of those and used the values from the example blog article. And then I needed the initial trend date or the initial trend value, which is this measure right here. So this is equivalent to this function right here. All right, and I'm not going to go through the DAX in depth to explain it all, what's going on, other than, you can see using this generate series here, I'm doing a for loop essentially within DAX to get my values, and then I can, calculate out what the result should be. And if we would actually like create a card visual here, pop that on there and do the initial trend, you can see comes out to negative 0.7847222222. And that actually it checks out with the Python code. As you can see, once they do it in Python, it's negative 0.7847222222, repeating. All right, so that was that piece. That was relatively simple. The next, I have and this is all 24. We want to predict out 24 periods. All right, so the next piece of this is we had the initial seasonal component. So I initially thought, well, maybe I'll do this as a path, essentially. That ended up not working out, so I just kind of, essentially, my first seasonal table is that code, exact same code, and then I just return a result, and then that gives me this seasonal 0 table. If I can find it. Let's collapse this up. And again, if you go in here, this is my initial seasonal table, and so this is the implementation of this next function, which is this initial seasonal components. So this Python code became this DAX code. As you can see, I have for loops in here using generate series. I'm not going to go into exactly how but this returns the same results. So if we just take a look at like negative 7.430555 and negative 15.097222, and I go back to the Python code, you can see down here when they execute 0, negative 7.430555, 1, negative 15.097222, and I went through and verified that all of these numbers matched with the example. So all of these numbers that came back. And yes, I did write all this Python code and check it out that way as well. So the next piece was how to implement this monstrosity, right? Which is where the kind of the recursive element comes into play. And not fun. So the way I just chose to do that was to implement tables for each one of them. So if you notice from the Python code, like, the initial case was pretty simple as far as this code goes. This code component right here is the initialization. And so that is my forecast 0. Obviously, my seasonal 0 came from the previous function that we just reviewed. And then I could get my first forecast, which I'm preserving my smooth, my trend, my last smooth, my seasonals, my result, my index. So that for all of the other steps, well, the other historical steps, we'll get to this one in a minute. All the other historical steps, I have to implement this. And so the way I was able to do that was I would create a seasonal table, which would come in here and modify. As you can see, it's modified the one. And so what I'm doing is I'm grabbing my previous seasonal values. I calculate out my new seasonal value for whatever one I need to do it in, which happens to be month one in this case. Um, and I calculate out, and then I just union them together where I take out the one and I substitute in the new one. And so each of the seasonals does that. Once I have the seasonal table, then I can use that in my forecast. And you can see that here where I preserve my last smooth, which was 30, and my seasonal values, and my result is right there. So that's my prediction for the value at that point. And it does all these match, right? I had to go through it. It was a miserable thing to do. And because basically what you have to do is you have to go through and copy and paste this 70 sometimes, right? And you have to, for each point, you have to say, okay, this is forecast 10, index 10, seasonal 9 on my previous forecast, 9 is my previous forecast, seasonal 10 is my current seasonals, do the calculation, and then you get to copy and paste that code to 11 and change this to 11, change this to 11, 10, 10, 11, and so on and so forth 70 sometimes, right? But you're also doing that same process for the seasonals. So in the seasonal table, you get to change the index to 10. This is my previous seasonal. This is my previous forecast. Do the calculation. And then you can copy and paste that to 11, change this to 11, change this to 11, change this to 10, 10, and so on and so on 70 sometimes. Not a pleasant experience. Again, it took me all Sunday to basically code this all up and figure out all this on how to do it. So that implements that portion of the code. Really nasty stuff. And then finally, for the predicted values, right here, I could implement that as a measure. So if I come down here to series, I come down here to prediction. So this is what implements that portion of the code. And there's my predicted results. So there you have it. And I think this is, yeah, so this is count rows. Yep, that's Len. I'm trying to remember exactly the way I did this. Yeah, so oh, that's my series. Never mind. Duh. That's a measure. So the measure actually executes then. And what I did to get this all to work, because I obviously don't have those index values, I created an indices table. I can find it. Create an indices table where I grab my indices, and then I generate series from 72 plus 23 in increments of 1. That gave me my index values for these, right? And then I also created a forecast table, which unioned up all 71 different forecasts. So that gave me a single table that I could use for the dark blue line right here. And then my measure I could use is this orange line right here, which gives me my predicted values out in the future. So simple. This is, I'm a glutton for punishment. This came in as like a LinkedIn request from somebody I really don't even know that well. And they're like, but it looked like an interesting problem. And I'm a sucker for the impossible problems in DAX to solve. But this one, I was pretty miserable when I was going through and doing this, especially copying and pasting 71 times and making sure I verified all of the different every single point was exactly the same as the Python example. Because you just fat finger one thing and it's all wrong. So anyway, so this is how you implement the Holt-Winters algorithm in DAX. If ever there was a case for why we really need a previous value function in DAX, boy, is this one it. Because that would save a whole lot of misery. And maybe somebody out there can take this example. I'll throw it up as a PBIX. And maybe somebody can take this and they can optimize it and like, oh, great, you could use generate and do this and that, and you don't have to have all this stuff. maybe there's a way. I didn't even go down that path. I've been down the recursion, aka previous value path with DAX so many times and just been utterly frustrated. I tried it with Runcutta. I've tried it with the Fibonacci series. I've tried it probably a dozen different times, and without success ever. So I don't know if there's a way to optimize this any better than the way this is doing it. Yes, you could implement these as maybe columns. You could do it all within vars within DAX. That might get some really nasty nesting involved. Who knows? But is it possible? Yes, it's possible. If you want to just yeah, just to beat yourself up and spend an entire Sunday copying and pasting code. Anyway, that's all I had for this video. Hope you enjoyed it. I don't know if this will be any use to anybody, but if you ever need to replicate the Holt-Winters in DAX, here you go. Everybody have a great Christmas. If I don't talk to you before then.